Computing with scientific notation. Essential question, how does scientific notation make it easier to perform computations with very large or very small numbers? Alright, so I've got a question for you. Email. Nearly 130 billion spam emails are sent worldwide each day. That's a lot of spam email. You think you get a lot. Alright, I want you to first find out how many are sent each year. That's how many there are per day, how many per year. We're going to use scientific notation to help us solve this. First question I have for you is I want you to write 130 billion into scientific notation. I went ahead and wrote it in standard form for you, but write it in scientific notation. If you do, you should have 1.3 times 10 to the 11th power. Next, I want you to round 365 days into scientific notation. So first, we'll round 365 to 400, and that as scientific notation is 4.0 times 10 to the second power. How could we write a multiplication expression to represent the total emails sent each year? So I could just multiply those two scientific notation numbers together, just like that. Lastly, I want you to use the commutative property to simplify. Move this up a little bit. Here we go. So commutative property says, look, I can go and multiply the 1.3 and the 4.0 together first, and then multiply the powers of 10 next. And that's what I showed you here. So 1.3 times 4.0 is 5.2. 10 to 11 times 10 to the second power is 10 to the 13th. And that's scientific notation, but all written out, that's this humongous number right here. That's how much spam email is sent out every year. So let's go through this process again. I've got another problem here. I'm going to multiply these two scientific notation numbers together. So here's what I'm going to do. First thing, I'm going to rewrite everything. I'm going to use the commutative and associative properties to rewrite it. So notice I took the number portion, the factors here, and multiplied those together. And then I took the powers portion and multiplied those together. Why? Because I really wanted this here to make my life easier. You can use the calculator and find out that 7.2 times 1.6 is 11.52. And then using the product of powers property, I can add those exponents to get 10 to the 7th power there. A little bit of a problem though. This here is not in scientific notation. So I need to change it to scientific notation. I'll move the decimal over one spot, making the number, which was larger, a little smaller. I take that power of 10 and I just add it to the one that I have here. So 7 plus 1 gives me my 8. Why 1? Because I ended up moving only one spot over. So there's my scientific notation. Okay, you try this problem. Rewrite them using the commutative property. Use the product of powers, and then make sure that it's in scientific notation. First step should look like that. Notice I multiplied the factors together, and then I put the powers together using the commutative and associative property. Next, I multiplied. I got 21 for the first factored product. Product of the factors, I should say. And then over here, 10 to the power 2 and 10 to the power 6 gives us 10 to the power 8. That's using the product of powers property. Well, I notice again this is not in scientific notation yet. I need to move it over one time. So since I moved it over once, that power of 10 is added to there. And there you go. There's your answer. Let's try that one more time. So I've got another example. Go ahead and try this out. First thing you should have done is to use the commutative property to rewrite these things. Multiply the factors first, and then you're going to multiply powers of 10 next. I used the calculator and I got 3.156 times 10 to the first power. Y to the first is 4, and added to negative 3 gives us 1. I use the calculator to find it. Here I can stop because it's already in scientific notation. Let's try one other type of problem. So the world population, this right here, see that's in hundreds, thousands, millions, billions. 6,860,000,000. Whereas the U.S. population has about this much. I don't know how many times larger is the world population, sorry I wrote U.S., than the U.S. population. I haven't figured that out. Well, we can take the the world population and divide it by the U.S. population. So the world population, I'm going to round this. This is really close to rounding this up to, remember, it's not 100,000 million per billion. So I'm going to say it's approximately 7 billion. So that's 7.0 times 10 to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, to the ninth power. And then I'm going to divide that by the US population, which is 3.0 times 10 to the eighth power. Okay, so I'm doing a little bit of rounding there to figure that out. Now I've set it up like this. What I can do is I can use the associative property and go ahead and just kind of take things one at a time. I'm going to go do the 7.0 divided by 3.0, that part. And then I'll end up multiplying that with 10 to the 9th over 10 to the 8th. Okay, and so this should look familiar over here. I'll do this part first. 7 divided by 3. So if you use your calculator, you take 7 divided by 3, you're going to get 2.3 or thereabouts. Over here, we can use the quotient of powers property. Remember, when the bases are the same, we can subtract those exponents, so I get 10 to the first power. All right, so there's my answer. It's 2.3 times 10 to the first power. If we actually expanded that out, that's about, and we rounded, so we could say, move it over, it's about 23 times larger. The U.S. population, I'm sorry, the world population is about 23 times that of the United States. So that's it for your notes. Go ahead and finish those up and make sure you write your questions and summary when you're ready.